Anybody happen to be at home doing your laundry, use a fabric softener, you think it contains a quaternary ammonium salt? Did anybody happen to look at a bottle of mouthwash and see if it contains a quaternary ammonium salt? Anybody at least look at a bottle of vinegar and think it contains acetic acid, which is a carboxylic? Boy, just a few. Boy, this is a tough group. I don't have much time to work with you guys. Remember, organic chemistry happens outside your door, all around you. It's well worth to think about it.
Question. You know those dryer sheets you put in the dryer?
Which what?
The dryer sheets. Are those like the same thing as fabric softener?
Yeah, well, almost. The difference is the anion. I don't talk about it, but in the washing machine you have chloride anion. In the dryer sheet you have what's called methyl sulfate anion. That's because chloride anion in a dryer will corrode the metal, and you don't want that to happen. And therefore, that's the only difference. Usually they're the same nitrogen part of the quaternary. So essentially, yes, they're the same molecule. The dryer sheet, I think I mentioned, is much more effective in softening your clothes than putting it in the washing machine. Quick commercial from Dr. White. I'll be teaching the summer of this course. If you know anybody who needs it, tell them to sign up because it's filling up quick. I also, if you know anybody who lives in Kane County, which is around Elgin, I also will be teaching the same course. It's called Chem 170 there. So spread the word. Or warn them, don't take me. Reminder, on Monday, I'll be going through the carboxylic acid semester's problem set. I highly recommend you practice those before I go through the problem set in class. Always, haven't said in a while, during the problem set, and all the time, even outside of class, remember, there's no such thing as a dumb question in my work. And if I remember correctly, this is where I ended up yesterday. I see a few people saying yes, so I guess I did remember correctly. But I don't think I did a synthesis problem. So let's take a look at it. What I was talking about yesterday was hydrogenation of a nitrile. Nitrile is a carbon-nitrogen triple bond. And remember, any triple bond is 2 pi bonds, 1 sigma bond. You can break pi bonds like that by adding hydrogen catalyst. Catalyst can be nickel, platinum, or palladium. And when you do that, each atom of the triple bond gets 2 hydrogens. Another way of writing this is this. A primary amine. And I was thinking about it, the company I used to work for that did this reaction to make primary amines, we made about 2 to 3 million pounds a week of primary amines to be used for either sales or other things. To give you an idea how much that is, tank wagon, you know, the vehicle that delivers gasoline to a gas station is 40,000 pounds. So figure about 25 of those per week, just this one reaction. And that's how it works in the chemical industry. It's big scale. All right, let me give you one to try here. All right, let's try this one. What would be the organic product or products we're following? I might be wrong, but I think 2 weeks from today is test number 3. It's coming up soon, I know that. And next week's lab is pretty quick. So we can go, yay. And what I will do, both for Tuesday and Thursday is, because the lab is so quick, you'll be in and out in under 5 hours. But anyways, it's quick. I will stick around for at least as much time as anybody needs me next week in each lab. If you have any questions or you want some practice, stick around after your lab and I'll be more than happy to provide. All right, let's take a look at this. And what do we have here? What's different? Nitrogen, and it's triple bond to carbon, nitrile. What are we reacting with? Excess hydrogen and nickel as a catalyst. What happens? You break both pi bonds. You break carbon-carbon single bonds? No. So this is my R group. I'm still going to have it attached to that carbon. I'm going to break both pi bonds. Each atom of the triple bond gets 2 hydrogens, and I get that amine, which I'm running out of room there, so I'll write it here. You could have also written it this way. And you get a primary amine. Now, as I mentioned, on test number 3, I'll have at least 3, possibly 4 syntheses. And I'll ask you the following: what would be the starting material for the following 3 points each? And as I've said, synthesis is the fun part of organic chemistry, because you figure out, how am I going to make something? Yes, ma'am.
Do we have a problem set due for Monday?
Yeah, I mentioned earlier, but I'll mention again, good question. Remember, on Monday, it's not due, but I will be going through the carboxylic acids and esters problem set, and I would highly recommend you practice before, because test number 3 will be like test number 2, and I'll put it up, but it'll probably be 9 pages. I'll have about 10 points general knowledge, about 35 points nomenclature. Here's the structure, give the exact name. Here's the name, draw the structure. And it will have 60 points on reactions, which means it adds up to 105, so there's 5 bonus points. All right, let's take a look at it. Well, let me see. Looks like you're all done, so let's do this. And think about this. 6 months ago, if I put this on the board after showing you that, would you even have the slightest idea to know what to do? No, you do. Doesn't that feel good? All right, what's different? Ooh, nitrogen. and it's a primary amine. And how do we make primary amines? What do we react with hydrogen and a catalyst? A nitrile. Now, let me remind you about something. I guess you call it common sense, but it's the best mentor I ever had in my life. Sid Shapiro used to beat in my head, common sense is not common, and it's so true. Mistakes students make is they don't know how to use common sense on a test. I've got 3 carbons here, 1, 2, 3. Am I adding carbons? No. So how many carbons do I have to start with? 3. All right, if I look at this, the carbon bonded to the nitrogen is the carbon and nitrile. Everything else attached to it is my R group. Therefore, 2 carbons, then my nitrile. Since I know how to count up to 10, let me see if I did this correctly. 3 carbons, 3 carbons. Because some students, for some reason, will do something like that, make that CH3, and that's 2, that's 3, that's never going to happen with this reaction. And that's how you make nitriles. And again, the reason you make nitriles is you make primary amine. What can you do with a primary amine? Secondary amine, tertiary amine, make it into quaternary amine, which company I did all those steps, and sell it as fabric softener molecule, or other amines made into quaternary ammonium salts or biocides. Ooh, that reminds me, I almost forgot. Time to gross you out. How many of you have ever gone into a big box store, supermarket, or a place like Target or Walmart? And most of them have it now. They have those little towelettes in the canister you can pull out to clean off your shopping cart handle, which I hope you all do. And I'll tell you why in a second. And you can buy them yourself at stores, and they disinfect. If you look at the label, when they have a quaternary ammonium salt, that also some ethanol or isopropyl alcohol, but quaternary ammonium salt, usually R is about 14 to 16 carbons. R prime and our double prime are methyl. Our triple prime can be the same as R, or it can be benzyl, CH3 with a benzene, or CH2 with a benzene ring on it. And those are all excellent biocides that kill bacteria and germs. Now, why do you want to do that? Time to gross you out. I remember reading at least 2 reports over the last 10 years. I keep up on things with quaternary ammonium salts, where they talked about how when people had done research and swabbed the handles in the area of a shopping cart, 70%, at least that much, I think it was at least 70%, had fecal matter on it. So, well, you think about it, what do you put in a shopping cart there? A baby. So, after I read that, I religiously used those. I said I'd gross you out. All right, let's move on now. You've learned about nitriles. Let's learn something about the chemistry of an amine. And one of the most important things is the fact that amines are bases. Now, what's a base? A base is something that accepts a proton. Hopefully you learned that in general chemistry. And one of the strongest bases is ammonia. And what does ammonia do when you put it in water? It accepts a proton from the water and becomes ammonium hydroxide. And when you go to the supermarket and buy, the ammonia solution they sell for cleaning and all that, it's really ammonium hydroxide solution. I have it here like this, but it's really in equilibrium. And what you smell is a very small amount of the NH3 ammonia, which is quite, how should I say, pungent, potent, knock you off your feet. I've worked with pure ammonia, liquid ammonia, not in water, and that's strong stuff. Well, what does that mean? Amines are bases. When you react it with an acid, you'll have a proton transfer and make an amine salt. So let's take a look at this. to stick to HCl. Why? Because that's the acid in your stomach. And if I take hydrochloric acid and react it with an amine, here I'm showing a primary amine, but the same will be true for a secondary or tertiary amine. Proton transfers over here. So if I add H plus, 2 plus 1, 3, one more proton or hydrogen, but it'll be a plus charge. This loses H plus. I have a chloride anion. All molecules in nature have a net zero charge, and this is called an amine salt. So if I take, I don't know, let's do one. If I take hydrochloric acid, usually you're going to do it in water, but just HCl, and react it with an amine, what do you get? Well, what's the product of this reaction? This is an amine, it's a base, this is an acid, I have proton transfer. What's my R group? 2 carbons, they're not going to be changed. I have my MH3, Cl minus. If you don't want to put charges, you don't have to, I will. And you make this amine salt. And the key thing is, an amine is a base, something that accepts a proton. Why don't you try this one? What would be the organic product or products for the following? All right, looks like everybody's done. And let's take a look at this. And what do we have that's different? Nitrogen. It's an amine. What's HCl? An acid. And other acids will do the same. Any amine, now here I'm showing a primary amine, plus an acid gives an amine salt. And now, what is R? In this case, isopropyl group will still be there. Nitrogen will now have 3 hydrogens plus charge. Chloride anion. If you forget the anion, I'll mark it wrong. Just no molecules in nature have a charge. They always have to have a 0 net charge. Now, as I say here, this will do the same with all amines except quaternary ammonium salts, because the non-bonding electrons, which help make it a base, are tied up. And therefore, if I were to do this following, and the question would be, what's the organic product or product? And I'll do this one. You look at that and say, what's different? Ooh, an amine. An amine, in this case, a tertiary amine, but still an amine, reacting with an acid. What happens? Proton transfer, which is what a base does, accepts a proton, will now have a plus charge, and you'll get the amine salt. In this case, what's our prime and our double prime methyls? They'll still be on the nitrogen. It will get one more hydrogen. It's got 0, now has 1. This will have a plus charge. And this will also have the chloride anion. And again, all amines are bases. They accept protons. And I would ask you the following on the test. What would be the organic product or products for the following? I think everybody's done. Let's take a look at this. And the question is, what's the organic product or product? Look at this and say, what's different? Nitrogen with carbons. This is an amine. In this case, it's a secondary amine. But all amines are bases. Add an acid, proton transfer. The nitrogen gets an H+. And you have a chloride anion. What's R? Methyl, or you can call it R prime. What's R prime? Ethyl. So notice I'll have 2 hydrogens on there. You can what's attached to the nitrogen is still attached to it. You see it now? And I'm going to move the chloride down, even though normally I'll put it here. This is one way of writing it. You could have also written it this way. And there are other ways too you could write it. And either way, it's an amine salt. Now, one of the things I would like you to know how to do is name amine salts. And I'll just ask you to learn the common names for amine salts. I don't even have a slide. My doctor would have got lazy, I guess. And how do you do that? Use the same nomenclature rules you use for common names for quaternary ammonium salts, which is name each R group, as an alkyl group and put that in the front. and then you add the phrase ammonium halide. Now, one of the questions students will ask is, how can you tell the difference between amine salt and a quaternary ammonium salt if they name the same way? Well, quaternary ammonium salt will have 4 groups, and amine salt will never have 4 groups. It'll have 1, 2, or 3. So let's take a look at one. I forgot to do this, so I'll remember to do it now. By the way, don't forget, videotapes of my lectures are on YouTube. We look at this and say, what's different? Ooh, nitrogen. And it's got 4 things attached to it, but not all 4 are alpha groups. And therefore, this is an amine salt. And how do you name that? You say, well, what's the alkyl groups on nitrogen and propyl? Then ammonium and chlorine becomes chloride. And that's N-propyl ammonium chloride. Why don't you try this one? What would be the common name for this? On test 2 in nomenclature, I'll have give the common or IUPAC name for molecules. There's a couple of things I haven't asked you to learn the IUPAC. All right, looks like everybody's done. Let's take a look at this. What's the, positive charge anion, positive on nitrogen. Do I have 4 groups on that nitrogen? 4 alkyl groups? No, I have less than 4. This is an amine salt. What are my alkyl groups? Methyl, how many? 3. How do we denote 3? Trimethyl. And then it's an amine salt, ammonium, and the anion is bromide, if I can spell it. And that's how you do it. And let's practice one where here's the name, draw the structure. I'll let you try this one. What would be the structure for the following molecule? All right, looks like everybody's done. Let's take a look at this. How do you decode this? You start from that end, and you look and, oh, ammonium iodide, nitrogen with a charge, iodide anion, and, ooh, this could be amine salt or quaternary ammonium salt. How many alkyl groups do I have on the nitrogen? 2, so it's an amine salt. Let's put the 2 alkyl groups, T-butyl. Now there's 2 ways you can write this. I have my di-T-butyl. Now, with an ammonium compound, there's always going to be 4 bonds to nitrogen. This is 2, 4 minus 2 is 2, so I have 2 hydrogens plus charge. Oops, I have chloride on the mine. And that's how you do it. Now, one of my favorite questions I ask you to ask in my class is, why am I learning this stuff? And you know the next thing I'll say, because someone told you you have to take a class, is one reason you want to get a good grade, but the other reason, what good is this? Well, it turns out ammonium salts play an important role in medicine. And when I say medicine, I'm talking about the things you take, various things like over-the-counter medicine and prescription drugs. If you look at the label, you'll see a number of the compounds, the active ingredient in the over-the-counter or certain prescription medicine are amine salts. You'll either see a long name in ammonium chloride, ammonium, usually it's chloride, or you might see a long name, and then a dot, and then HCl, which is an amine salt. Why do they do that? Well, it turns out by making an amine salt, by making an ionic compound, it's more soluble in water. And why is that a good thing? Because if you take it, it goes in your stomach has water, it makes it soluble so it can go into your blood, which has water. Hopefully I'm still right on this, I'm well beyond my level of expertise now. So I'm an organic chemist, not a biologist, but nothing wrong with that. I always knew I wanted to be an organic chemist. And if you go home, look at somebody like your cough medicine or other over-the-counter antihistamines, things like that, you'll see the active ingredient is an amine salt. Another area amine salts play an important role is to adjust the pH of something. If something is too acidic, it will irritate your skin or do bad things to your hair. That's right.
Why is it NH2 over there, but it was just NH on the others?
All right. Remember, in an amine salt or quaternary ammonium salt, there's 4 bonds to nitrogen. Okay? So let's take a look at a couple of different amine salts. If we look at this one I have on the board, it's going to have 4 bonds, and 1 or more of those bonds is going to be hydrogen. So now I have 2 alkyl groups, and I have 4 bonds, 4 minus 2 is 2 hydrogens. Let's try the one I had before. I don't remember the anion, it's the chloride. It's an amine salt or a quaternary ammonium salt. This gives it away. On my test, I always put charges. And it's going to have 4 bonds to nitrogen. Ammonium means 4. And therefore, I have 3 alkyl groups. 4 minus 3, I need 1 hydrogen. Let's do one more and see if I'm... That's a very good question. And now you'll know how to do it. Everybody else who was not sure about it will be. Why did I put down 3 hydrogens? Because how many alkyl groups do I have? 1. Therefore, 4 minus 1, ooh, I got it right, is 3. And that's why. Because if you look at an ammonium compound, there are 4 bonds to nitrogen, 1, 2, 3, 4. And if one of them, each one that's alkyl, the rest of them have to be hydrogens. And this will have a plus charge when it's like that. And it will have some anion too. And that's how you know. Where amines, and this is where it gets a little confusing because all semester up to now, I've brainwashed you, literally, 4 bonds to carbon. That never changes, nor should it. But that's the difference between different elements from our periodic table. I know what I was talking about. If you look at some of your hand lotions or personal care items, air conditioners, shampoos, things like that, you might see the name ethanolamine, diethanolamine, or triethanolamine. And ethanolamine is a common name for this structure. Di means there are 2 of them on here. Tri would be 3, CH2, CHOH on nitrogen. And these are all bases. And it's something that if there's excess acid, they put it in there to neutralize it so they keep the pH near 7. And what you get is the amine salt. And of this product, this is not bad for your skin. And they use an amine like this one to help make sure that what you use on your skin has a pH around 7 or a little above that. Because if it's way low, like 3 or 4, if you put something on your skin to make your skin nice and soft and feel good, and you look and see it's all red and blotchy, are you going to be happy with that product? I don't think so. Now, once you have amines, what can you do with them? You can make it into, it's time for a new functional group. And that new functional group is called an amide. And amides are made from amines, amine derivatives. And this is another area I work probably in. Amide, carbonyl with an R group, nitrogen. On that nitrogen, you have R prime and R double prime. And this is called an amide. Now, for amides, R prime, and R double prime can be hydrogens. For the most part, for you, you should know. R and R prime can be hydrogens. And this is an amide. It's a derivative you'll see made from an amine. And this is an amide. Now, do I have time? Yeah, I have time. Special gift time from Dr. White, little gift. Since most of you aren't going to do a lot of work in amides, I'm not going to ask you to learn the IUPAC nomenclature for amides. And I won't ask you to learn the common names for amides, but you should know what the structure of a general amide is so you can identify the functional group. I'm going to skip this slide. I forgot to take it out. Promise I'm sure. You can have cyclic amides, and these are called lactams, but they're still called amides. The reason I want to bring this up is when we go into chemistry, I'll talk about this. The ACS, just like they put lactone cyclic esters on their final, which now I put on my test number 3 to give you a little practice, because when I didn't, students always got those problems wrong. This is a cyclic amide. Now let's take a look at it. And you can have 5 or 6 membered rings. If we look at this, what do I have? Carbonyl. So carbons here. Carbonyl to nitrogen. And notice one of the R prime is hydrogen. And our prime, double prime is a CH2, but just so happens this is connected to that in the ring. And this is an amide and reacts just like any other amide. Now I'll go through the chemistry. Now, one of the questions you, as I mentioned just a little while ago, why are you learning this stuff? Oh, I'm ahead of myself on that question. The simplest amide, it turns out, can also be NH2. And this is an amide. It undergoes all the reactions of amides, the same chemistry, even though it does look a little funny. If this were an R group under my hand, you'd say, oh, that's an amide, nothing special. If this were an R group under my hand, you'd say, oh, that's an R amide, where R prime and R double prime are hydrogens. Well, it turns out this is the simplest amide, and it's got a name you should know. And that name is Urea. And urea is a white solid at room temperature, very soluble in water, and it's a major organic compound, and it's used in industry, and it's also the main organic compound in urine. It's how your body gets rid of one of the ways, nitrogen waste. And I've had an interesting memory because one company I worked for, we used urea to make polymers, which I'll talk more about. And we were using it for a reaction that I came up with, and I was in the plant, and they sell these in what's called super sacks. Super sacks are big bags. They're about this wide, from the floor to this side, about that. And it should be a nice powder, you know, like the salt or sugar in your, when you buy it. This was all caked up. And it was a fun morning with me and 10 other workers in the plant with sledgehammers breaking it up so we could get it into powder. That was not a fun morning, but I got a good workout with the sledgehammer. But urea, like I said, is the major component in urine. As I said, my world of organic chemistry is your world. It's everywhere. Now, when you talk about amides, why learn about amides? How many of you are familiar with hot peppers? And I think most of you know the different ones. There's habanero, there's the regular, what's one of the standard, jalapeno. They're green peppers. There are all sorts of peppers. They're the Thai chili peppers, you know, and there's different levels of hotness, how hot it is. And what makes it, you don't have to copy this down. This is the chemical capsaicin that's in peppers. The more that's in it, the hotter it is. Habaneros and the ghost peppers, and they have a large amount. Jalapeno, much smaller amount. Green peppers, red peppers, almost nothing. And one of my favorite places to buy things from, the Spice House, a number of years ago, they started selling powdered habanero, which is one of the most dangerous and amazing stuff. So I bought a bottle, it's a powder, and I did one of the stupidest things in the world I've ever done. I went home and said, wow, I wonder how hot this is. I went like this, uh-oh, I just made a bad mistake. My tongue was on instant fire. My lips were burning. And luckily, I'm an organic chemist, and I said, well, how can I get this out? And I'll teach you later in the semester, but I'll teach you how to do it now. I'll teach you the chemistry about it. There's a principle, a rule of thumb called like dissolves like, something that's non-polar, soluble, non-polar things. This is non-polar. Notice it's an amide, and also has a phenolic ring in it, benzene with hydroxyl, ether here, double bond. But this is non-polar. And how do you get it off your tongue and everything? Water is polar, it won't touch it at all. And how many have heard drink milk or other things, crackers? Well, what's in the milk? The fat. And I didn't have any milk. Well, what else has a lot of fat? Well, vegetable oil, but I was right next to my refrigerator. I opened the drawer, I have my utensils, took out a spoon, open my refrigerator door, grab the mayonnaise, which is 50% oil, 50% water, enough oil, took a couple spoonfuls of mayonnaise, swished it around, spit it out in the sink, did it a second time, stopped it immediately, but it was painful, dumb. Never, ever take some habanero powder and say, when I have a big pot of chili or something like that, I have micro spatula, which I just put a little in, where I just know, if you put too much, you taste that, you might as well throw it out because your mouth's going to be on fire. But it also, I love hot stuff, so this is amazing stuff. But I don't like hot burger and bang. It reminds me, in Arlington Heights many years ago, there was this one Indian restaurant that opened up. And I went there with some friends because I love Indian food. And all the stuff was just burning your mouth out, painful, hot. And within about 3 or 4 months, they went out of business. Yes?
Does the horseradish kind of have the same thing, or is that a different?
I would think so, but I'm not sure. I'll have to look it up or email me. Oh, that reminds me. My grandma Greenman was a very playful person in terms of you have to watch out because she'd play tricks on you. And for certain holidays, I'd go over to their place when I was very young and spend the night before with my grandmother and grandfather. It was a fun time. They're great people. And she was a great cook. This is back when you make your own horseradish, which you take the horseradish root and grind it. And I'm saying, Grandma, what's that? Horseradish. Oh, what's it like? She said, you're going to smell it. Next thing I knew, I was on the floor. It was so strong, it knocked me out. And she's standing there laughing. I'll teach you to stick your nose in the thing on horseradish. Am I out of time? Oh, wait, I got one more minute. Nah, I'm going to let you out early. Take a whole 50, 65 seconds. For those of you who do not have labs, have a nice rest of the week and weekend. Don't forget to do the problem set. For those of you who do have lab, I'll see you in a couple minutes. Also have a nice rest of the week and weekend. Don't forget to do the problem.